One feature of medieval Indian mathematics is an interest in combinatorial questions arising from lyrical structures. A line of poetry has some duration in time, what they call matra, some number of syllables, varna, and some of which are stressed, guru, and some of which are unstressed, lahu. And this leads to a generic question: how many ways can you construct a line of poetry with certain constraints? Now, Pingala solved the problem initially where the syllables might be stressed or unstressed. His work would be extended by Halyuda by the 10th century. The general problem is a combinatorial one. Given n objects, how many ways can you choose k of them? Halyuda's solution is known as the Meru method. Set down a triangle of boxes, the Meru, a sacred mountain in Vedic cosmology. At the top and first row, put ones. In all the remaining rows, put ones at the end. The interior entries are the sum of the two boxes above. This corresponds to our construction of the arithmetic triangle. The arithmetic triangle is often called Pascal's triangle. While many others had described the triangle before him, including some European authors, the name is still warranted because previous authors described the construction of the triangle, but Pascal was the first to write an extensive treatise on its properties. However, Halyuda did make an important observation. So this first row, ignoring the peak, is the number of one-syllable lines. We can read this as indicating there is one one-syllable line with a heavy syllable and one one-syllable line with a light syllable. Now, suppose we add a syllable. So if we add a heavy syllable to the one line with one heavy syllable, we get one line with two heavy syllables. This corresponds to the one that is below and to the left of the leftmost one. But if we add a light syllable to the one line with one light syllable, we get one line with two light syllables. And this is the one below and right of the rightmost one. So what about lines with one heavy and one light syllable? We can get these by either adding a light syllable to the one line with one heavy syllable, or a heavy syllable to the one line with one light syllable. And this corresponds to the sum of the two entries in the first row. Now, notice the entries in the new row. We can read these as telling us there is one line with two heavy syllables, two lines with one heavy syllable and one light syllable in some order, and one line with two light syllables. If we add a heavy syllable to the one line with two heavy syllables, we get one line with three heavy syllables. Likewise, if we add a light syllable to the one line with two light syllables, we get one line with three light syllables, and these are the ones at the ends of the rows. So what about a line with two heavy and one light syllable? We can produce this by adding a light syllable to the one line with two heavy syllables, or adding a heavy syllable to the two lines that have one heavy and one light. And so there are 1 plus 2, 3 lines with two heavy and one light syllable. Likewise, a line with one heavy and two light syllables can be produced by adding a light syllable to the two lines with one heavy and one light, and adding a heavy syllable to the one line with two light, for a total of 2 plus 1 equals 3 lines. And we can continue the construction. So consider two adjacent entries in any given row. These correspond to the number of lines with a specific number of syllables where the entry on the left has one more heavy syllable than the entry on the right. So the left entry produces lines that have one more light syllable, and the right entry produces lines with one more heavy syllable, so their sum gives a number of entries with the same number of heavy syllables, because remember the one on the right had one fewer, and one more light syllable. And this is a proof that the Marrow method does give the numbers of lines with any number of heavy and light syllables. This recursive thinking shows up in another problem. The heavy syllables are generally considered to take more time, matra, than the light syllables. So even if two lines have the same number of syllables, they might require different numbers of matras. So another problem is, how many meters with n matras where the heavy syllables count 2 and the light syllables count 1? For example, heavy light is a 3 matra line. So is light heavy, that's 1 plus 2, or light, light, light. And so there are 3 matra meters. Virahanka, in the 7th century, noted that the solutions were for 3, 4, 5, 6, and 7 matra lines. Hemachandra pointed out that each term is the sum of the two preceding. Now, neither Virahanka nor Hemachandra explained why this works, but the logic used by Halayuka could be applied to this problem. So begin with the idea that there are 3 matra meters and 5 4 matra meters. If we add a heavy syllable to each of the 3 matra meters, we get a 5 matra meter. And if we add a light syllable to each of the 4 matra meters, we get a 5 matra meter. So the number of 5 matra meters will be the sum of the number of 3 matra meters and the number of 4 matra meters. And in general, we can produce a meter with any given number of matras by adding a light syllable to all meters with 1 fewer matra, or adding a heavy syllable to all meters with 2 fewer matras. So the number of meters with any given number of matras is the sum of the number of meters with 1 fewer matra with the number of meters of 2 fewer matras.